Big data has many different definitions. Some people refer to big data as in large amounts of data, and that is accurate, but that is only one definition. My name is Steve Macchio, Director here at L3 Data Tactics, responsible for our Big Data Ecosystem platform known as BDE. Big Data Ecosystem is a turnkey platform that has been designed to rapidly ingest both structured and unstructured data into the platform. It comes with some robust capabilities such as advanced search and query so that you can look for information across all of your data sets in one holistic view. The ability to visualize vast amounts of data very rapidly so that we as humans can understand patterns and categories within data that help us towards business intelligence solutions.
My name is Stephen Aberle, Chief Product Designer for Big Data Ecosystem, and I'm here to take you through user interface introductory training. Over the next several minutes, I'll be taking you through 7 primary user interface sections, including logging into the Big Data Ecosystem with a username and password, the Data Manager dashboard and Dataspace date distribution graph, the Cyber dashboard with network device monitors, the powerful search application named Discover, using advanced search tools such as facet and model-based queries, geospatial searches, heat maps, and analytic heat maps, and dynamic visualization and the business intelligence graphing application. Let's begin by logging into the system. Your Big Data Ecosystem system administrator will provide you with a username and password. Input your username into the first text block. Input your password into the second text block. If you want the system to remember your username and password, leave Remember Me checked. If not, uncheck that box, then click Login. Let's talk about the data management dashboard, but first I wanted to cover some of the layout that you're going to see in Big Data Ecosystem. You'll see at the top of the screen we have the header information with some options to the top right to go back to the dashboard, question mark for a help file, your settings, and a logout button. On the left side is the primary navigation where you see the applications that you have access to inside the ecosystem framework. Then there's the secondary navigation. On the dashboard you can adjust your profile information. And then there's the canvas area where we have the widgets and content of that specific application. So let's talk about the data management dashboard. There are 5 discrete widgets on the dashboard starting with top feed statistics. The top feed statistics widgets detail all of the data sources that you have ingested into the platform, giving the name and a description, the total number of artifacts, the ingest date, and the date size total, either in kilobytes or megabytes. It's paginated depending on the number of data sources you have. You could have a few numbers there on the bottom. But you can see the variety of data that we can ingest into the platform just by paging through the top feed statistics widget. So you see we've ingested Facebook metadata profile information, including FMV, full motion video, instant messaging traffic, Kiva lenders and Kiva loans, which is a finance and microfinance data source, along with a lot of different text messages, including USFK, US Forces Korea messages, and we have YouTube videos in this specific demo platform as well. To the right of the top feed statistics widgets is the records counts widget, where you'll see total number of records, however many records are in queue to be ingested, and whether any errors were thrown during the ingestion process. And right below the records counts widget, you'll see the dataspace distribution graph. Anytime there's a temporal component to data that's ingested into the platform, we log that temporal component, store it in the data space, and we can provide a representation of all the data that you've ingested across the system and where that is over time. So that's what the data space date distribution graph is. You can see we have data from 1970 all the way to references to 2044 future dates in the system. So if we zoom up into the main block of data that you see in the histogram, which would be somewhere from 1999 or 2000 to 2014. This is a representation of the spread of data across time that you have in the system. You can click on any one of the years. I'll click on 2012. And as you hover over it, you can see we have 2.8 million artifacts for that specific year. And I'll click on that, and you can see the distribution now for 2012 of the months from January to December. It looks like a large number were adjusted in September. I hover over that, and I can see 1.8 million artifacts just in the month of September. I can click on that further and get the days of the month, and data was ingested over 2 days in September. And I can click on the day of the month and get to when those records were ingested over hours. And so now you're looking at, looks like those records were ingested over midnight, 1 million records. I can easily get back to where I was, the first state of the data space distribution graph, by clicking the Go Back button. And you can see inside the header of the widget, the date adjusts. Now we're looking at the days of September. Now we're looking at the months of 2012. I hit Go Back one more time. Now I'm at the original state of the date distribution graph. There are 2 additional widgets on the Data Manager dashboards, which includes a multi-language word lookup. Simply input a word that you wish to look up in another language, select the language from the available dictionaries you have, whether you want exact matches only or also search the definitions of the word, and click the search icon just to the right of the word. You'll see an icon indicator that says it's searching through all of the dictionaries that we have, and then you have your results just to the bottom of that. To the right of that is the conversion tool. Select any number of variables to convert from: acceleration, astronomical, angles. There's about 25 of these. Input the number that you want to convert and the variables you want to convert from and to. So we'll convert 12 parsecs to light years, Julian. And hit convert, and you see in the bottom, you get the result: 12 parsecs equals 39 light years. That is the data management dashboard. The Cyber dashboard displays network devices connected to Big Data ecosystem and their associated activity. The dashboard opens to the primary view of all connected devices, with a graph showing the distribution of network activity over time. The graph also includes a nowcast predictive analytic that overlays trend analysis alongside the network activity distribution. I'm currently looking at network activity for 2014 of October. You can see the nowcast analytic along with the distribution of network activity over time. So for the 27th of October in 2014, the network activity is 359,000 hits. And I can click on that bar and show the distribution over time over that specific day. I can also look at the second tab, which is all device data. This shows a total number of records for all the devices included in the system, the size of the records in Big Data ecosystem, and any errors that were thrown. There's also a table that provides trend analysis that shows traffic volume for the last hour, the number of volume hits, and then the trend up or down percentage-wise, average hourly traffic over the last 7 days, and average hourly traffic over the last 30 days. We're currently looking at all the connected devices graph information. If you wanted to look at a specific device, you would simply click those specific devices in the secondary navigation. So I'll click on a couple different devices. That will show you the distribution graph associated with that specific device, along with the data for both of the devices. And if I wanted to arrange them according to my preferences, I just simply click in the head of the widget and move that widget anywhere I want. Discover is a powerful big data search application that goes far beyond simple keyword searches. You can search for very specific fine-grained items or concepts through all of your big data sources, or any combination of data sources. Discover provides ultimate query flexibility by allowing you to combine several different types of advanced searches together, making it easier to discover exactly what it is you need to find, and hopefully alert you to things you didn't know you were looking for or needed to find in the first place. You can, of course, input text for simple keyword searches and combine that with more advanced parameters that you would find on any search system, or any like Google Advanced Search. But the power of the system lies in its ability to perform fine-grained searches through facet and feature analytics and model-based queries. Global facets are located in the first tab of the Discover Search application. Simply scroll down and you see them just underneath sources information. Facets are features extracted from records that describe the who, what, when, and where of records inside Big Data ecosystem. These features are isolated inside the index search mechanism so that users can perform in-depth queries across all documents using specific descriptors. Doing this allows users to access only the specific information they're looking for, as opposed to broad keyword-based searches that we talked about before. So let's take a look at facets associated with the Facebook data source we talked about earlier. All I really need to do is go to the facets area inside the secondary navigation and type the word Facebook into the filter facets bar. That will give me sort of an autocomplete and a hint of some of the facets associated with them to be able to quick select them. But I want to look at all of them, so I'm just going to hit enter after I type the word Facebook, and you see all the facets associated with Facebook appear. So let's dig into just a couple of these real quick. Let's take a look at the facets associated with Facebook user friends. So if you twirl that down just by selecting on that first bar, you can see that there are 12 facets associated with it. It shows an upper and lower register, so a max and min for number of user friends, as well as the top 10 most frequent numbers of friends in the Facebook user profile metadata. So the maximum value of 7,569, the number to the right of 1 indicates that there's only one user that has that many friends. That's quite a bit of friends. The minimum register, or the min number of 0, there are 3,492 people who have that number of friends in the Facebook data that we pulled from an open source. So underneath the upper and lower registers, the min and max, are the top 10 number of friends for the Facebook user profile data. So of course the most popular number of friends is 0, and you can see again that's 3,492. The second most popular is 1 with 1,421 people with 1 friends. The next most popular number is 382 with 1,262 user profiles with that number of people, and so on. That shows you just the top 5. To get to the next top 5 facets, simply click on the next 5 button and you'll be able to see all of the top 10 Facebook user friends. So let's take a look at something that might resonate with you a little bit more, is Facebook user last names. So these are the top 10 last names inside the Facebook user profile metadata. And you can see the top most popular last name for Facebook happens to be Lee. That makes a lot of sense. Smith, Kim, Johnson, Miller. Again, if you want to look at all of the facets, simply hit the button for next 5 facets. And here are the top 10 last names for Facebook users. And of course you can see first name, and hit the pagination button to scroll through all the Facebook associated facets. To search on any of these facets, all you really need to do is click on any one of these facets that are described. So if I just simply want to look at Facebook users have the number of 382 friends, I simply click on 382 bar. You will see that green tag that shows up below the keyword input is Facebook user friends 382. That adds that as a search parameter. I'll go ahead and click search, and you can see some results that pop up here. There are 1,262, just like it said. Number of Facebook user profiles that have 382 friends. Let's take a look now at model-based queries, which are located in the second tab in the Discover Search application. Models can be defined through parsing the data at time of ingest, or discovered automatically through standard analytics. They build a structure and hierarchy of the data and provide the user fine-grained control of searching specific fields within the data. So, as an example, let's use the open source Facebook data again, and if you click in the Facebook area for build a model-based query, you see that we have discovered the highest level of information in the Facebook user profile is user. Again, that makes a whole lot of sense, and there are 10 structured fields associated with Facebook users. So let's twirl that down and let's take a look at all of the structured fields that we have access to and control over to search on. So you can see we have date of information, there's a first name, number of friends. You can see the difference between simple text values or dates or numbers in the system. During the parsing process, we automatically identify whether it's one of those three things, and in the user interface you have control over being able to search those things specifically. So the example we used for facets was number of friends, so let's go ahead and use that again. So I'm going to click on friends numeric query, the bar underneath user in the Facebook model, and I get a pop-up that asks me to input values to search on. So I could search on show me all of the Facebook users that have friends, the friends number of 382, or I could specify a range. So I just want to look at Facebook users that have 453 friends to a range of 492. And you want to add that query, and you can do that by clicking the plus sign to the right of the range bars. So we'll add that, go ahead and close that box out, and you can see the green tag appear underneath the keyword input area. We'll go ahead and search on that, and the results we should get are the number of Facebook users that have the number of friends 453 to 492. You can see plenty of users. If I click on any one of these, you can see the number of friends they have, 455 for Facebook user amebroder1. That is within the range that we searched on. So another example of very fine-grained control over queries and searches through model-based queries and facets as well. So I can combine this model-based query with a facet query for Facebook. And we'll do that real quick by looking for the Facebook facets by searching on them. And I just want to look at the Facebook users who have that range of friends with the last name of Lee. That should provide me with some results. So I'm going to go ahead and click search, and the results will pop up here in a second. I have 272 results, Facebook users with the last name of Lee that have the number of friends 453 to 492. Let's just confirm that. Facebook user Michelle Lee and 462 friends for that profile. So I've just combined a facet search along with a model search. Very powerful way to search through your data. Let's talk quickly about the geospatial search and geoanalytics capability of the platform. When locations are identified in data sources at time of ingest, they become eligible to display as a result on Discover's map. The Geo Query capabilities are located on the fourth tab of the Discover application here. And it includes options to change your preferred base map, as well as typical map options, for instance, to show map scale and track mouse location. You can turn those on and off by toggling the buttons to the right of those map options. You can perform searches, of course, through the Discover mapping and geospatial capability by simply entering keywords or inputting shapes on the map itself. So let's take a look at some of the map options we have available to us for searching. The first option is to draw a search area. And if I click that, you can see we can draw a shape, drag a circle, draw a route. Some other options here on the map are modifying a shape's point, deleting a shape, getting a hand to navigate around the map, or save your map position. So this option sets whatever location you're on as the map home position. So let's simply draw a shape here. I'm going to do this roughly around Romania, and I click around, add points to the map by simply single clicking and double clicking to finalize the shape. So let's draw a route now. So I'm going to move my map into Syria, And I'm just going to look for a route to draw here. So let's draw a route between Homs and Damascus, which looks like the road M5. So I'm going to go to my map draw options. I'm going to draw a route. And I'm simply going to click on the route from Homs to Damascus. And as soon as I reach my point of destination, which is Damascus, I double click. And you'll see an option that pops up for the route width. And really what this is asking you is how wide do you want your route line search area to be. So I'm going to say, let's say 7,000 meters and click OK. And immediately you see the search area pops up on the map canvas from Homs to Damascus. And if I searched any records inside BDE that have the location associated with that route and the width of 7,000 meters would then display. Distribution maps are a visual expression of analytics that run on data sources that have geolocations in their records. So locations inside records for all sources, or distinct sources, will have corresponding heat maps that display the distribution of all locations inside the data. You can look at the distribution of all your data sources, or again look at them separately by clicking on the source name in the secondary navigation area. You can also overlay any number of sources on top of each other for comparative purposes. So I'm clicking on AISX data right now, as well as CENTCOM, and you see how the two differ from the distribution maps and overlay on top of each other. And I'll click on a couple different ones, GeoNames. You can see that one is loading. And we'll just unclick all of these and we'll just simply take a look at the distribution map for all sources of information. The business intelligence aspect of BDE is brought to life through the dynamic visualization framework, which allows users to pose complex questions of the data and get immediate answers. Anything in the system that can be measured numerically can be graphed against textual attributes by simply clicking on the measure an attribute. So in essence, you can express a question with 2 clicks, and BDE will provide you with an answer on the 3rd click. As an example, what you're looking at is a business intelligence data source, whose raw format is a massive CSV file. It's important to note here that the dynamic visualization framework can display answers to questions from an array of data source types, not just Excel or CSV, an important differentiator between our competitors. So let's pose some questions of the data here real quick. So the first thing I'm going to do is, of course, click on a measure and an attribute. So as an expression of a question, I'll click on the number of new wells and I'll select an attribute of well orientation. It can be either directional, horizontal, or vertical. So I click on those 2 things. You can see in the top area of the canvas, they display now. I'll ask that question by hitting Create Graph button, and now you can see the answer displays the number of new wells by well orientation. There's 2,367 horizontal, 1,132 vertical, 491 directional. We can also view this information both by geospatial attributes and temporal attributes. So I want to view this information by the permit approval date, which is the temporal attribute we have in the data. So I simply click on permit approval date. You see that appears in the attributes section of the canvas, and I'll create the graph, and immediately you can see the most data I have is for 2014. I'll click on 2014 and I can see the distribution of the number of new wells by permit approval date, and it gives me a little bit more information than just say looking at the number of new wells by orientation by adding a temporal component into it. Now I can see the trends over time. It looks like August through November or September through November are the months that have the most activity associated with number of new wells. So let's just express a couple more questions by clicking on measures and attributes. So I want to look at the number of wells that are in prep. So something that would be important to me as a business development individual inside an energy company. And I want to look at that possibly by geospatial attribute. Let's get rid of these here. I want to look at the number of wells in preparation by state. I'll create that graph, and immediately I can get the answer. There are 169 wells in prep in Texas, and of course 32 Kansas, 45 in Arkansas. There's a big drop off between Texas and the other states. With that brings the introductory UI training to a close. We've covered everything from logging into the system to different types of dashboards, advanced searches through Discover and the BI framework in BDE. Come back and see us anytime at bde.data-tactics.com.